In this video, we're going to take a look at an example where we are going to do a hypothesis test regarding a mean. So let's take a look at the example and we will determine some of the specifics related to this example. So here we read, the weight in pounds of discarded plastic from a sample of households has summary statistics. N is equal to 62, X bar is equal to 1.911, and S is equal to 1.065 pounds. Use a 0.05 significance level to test the claim that the mean weight of discarded plastic is greater than 1.800 pounds. So we identify that this is a hypothesis test because it tells us that we are going to test the claim. Immediately after that, it tells us what the claim is. So the claim is that the mean weight is greater than 1.800 pounds. So when we do hypothesis tests, we identify the claim. So the claim is a claim about the mean, and it's that the mean is greater than 1.800. After we identify the claim, we identify the counterclaim, the opposite of the claim. So our counterclaim is if it's not greater than 1.800, it must be less than 1.800, or it needs to be equal to 1.800. So if it's not greater than 1.800, it is less than or equal to that. From these two things, we should be able to identify the null hypothesis, H sub O, so the original hypothesis, and the alternate, or the alternative hypothesis. So the alternative hypothesis will always show up as one of these two, either the claim or the counterclaim. It's not always one or the other, but it is one of the two. So here it is the claim, because the alternative hypothesis will always be the one that does not allow the two sides to be equal. So our alternative hypothesis is that the mean is greater than 1.800. The null hypothesis is always a statement that a population parameter, so the mean, population mean here, is equal to some value, and so it's that it's equal to 1.800. We also look back in the original problem statement and we see that we are given that the value of n is 62, so that is the sample size. X bar is the sample mean, that is 1.911. S is the sample standard deviation, 1.065, and 0.05, that is our significance level. We use an alpha to represent that. So 0.05 is our significance level. Other things I would maybe make note of here is that for our alternative hypothesis, it is a greater than sign. So this is a right-tailed test. It's a one-tailed test because that's a greater than sign. And specifically, it's a right-tailed test. And so what we're imagining here is something that is normal distribution-ish. Now, in fact, it's going to be a t-distribution that we're thinking about. And because our significance level is 0.05 and it's a right-tailed test, then we are imagining here an area of 0.05. And if we happen to live in that region, if our sample gives us something that lives in that region, then we are going to reject the null hypothesis because that is our region of rejection. All right, so let's go to StatDisk and do our hypothesis test there and have it come up with some calculations for us. So let's over here in StatDisk. We are going to choose analysis. Then we are going to choose hypothesis testing. And we are choosing to do a hypothesis test about a mean. Right? So it's a claim about a mean, that the mean is greater than 1.800. So it's a mean with just the one sample. And so we choose that. So now we need to input a variety of things. The first thing that's really easy to overlook is we need to choose the alternative hypothesis. So that's in this drop-down menu. By default, it will be that the population mean is not equal to some claimed value, but that's not what our alternative hypothesis is. Ours is the second one, that the population mean is in fact greater than some claimed value. It's that the population mean mu is greater than 1.800. Next, we input the value of the significance level, which is 0.05, so that value is okay. We are going to input the claimed mean. So this is not the mean from the sample. This is the claimed mean. This is the mean from the hypothesis, the null hypothesis. So the null hypothesis says, we think that the mean is 1.800. So that's from the null hypothesis, not from actually the original claim in the statement, where the claim is, we're testing the claim that the mean is greater than 1.800. This claimed mean is actually the claim from the null hypothesis. We input the sample size, and so our sample size here was 62. We input the sample mean, which our sample mean was 1.911. And we input the sample standard deviation, which was 1.065. Now notice that population standard deviation, that was not given to us, and so we're going to just leave that space blank. So we have those values, and now we can evaluate. And when we evaluate it, this tells us a variety of things. Right there at the top is our alternative hypothesis. The mean is greater than some hypothesized value of the mean. That's really just a double check to make sure that you have input the hypothesis, the alternative hypothesis, correctly. I always double check that. I take a look at that real quickly to make sure that that matches up with my alternative hypothesis. Now I'm going to jump down to where it has the p-value. So it's the fourth thing down. We have our p-value down here. And our p-value there is 0.2075 if we go to 4 places. So 0.2075. I'm going to go back to our example, and we're going to use that p-value to make a conclusion. So using our p-value method, we have 0.2075. How do we make a conclusion using the p-value method? Well, here we compare our p-value to our significance level, to the value of alpha. And so we observe that 0.2075 is actually greater than 0.05. So what does that mean? We have our p-value is high. It's larger than our significance level. The p-value is high, so the null will fly. So we fail to reject the null. We're failing to reject that null hypothesis. There is not sufficient evidence of the alternative. What this says in terms of areas, with this p-value of 0.2075, that's actually saying that for this sample, it would represent something like this. It has an area of 0.2075. Since that area is larger than the 0.05 area, then we fail to reject the null. We're not in that region of rejection. All right, let's take a look at a second method. Our second method that we could use to come up with ultimately the same conclusion is the critical value method. And so here we want to identify the critical value. And so our critical value is going to be back up in that graph. So the critical value is the value right here that has that area of 0.05 to its right. So the 0.05 is a significance level, but the critical value is this value right here. That is our critical value. And what is our critical value? Let's go back to StatDisk. Our critical value, it is a t-value. It's right above that p-value. So it's a critical value. It's a t-value. It's 1.670. 1.670. So that's our critical value. And our test statistic. The test statistic is going to be the value here that has a p-value of 0.2075 to the right. So our test statistic, it was calculated here. It's also a t-value. It is 0.820 or 821 if we round to 3 places. So it's a t-value 0.821. So if we compare test statistic and critical values, because that test statistic does not exceed the critical value, it's not larger, then we are not in the region of rejection again. So our test statistic is less than the critical value. And so again, we fail to reject the null. So we have a sample, and our sample gives a test statistic of 0.821, but our critical value is 1.670, so we do not have sufficient evidence to reject that null hypothesis. And let's look at a third example or third method to do the same thing. And so our third method that we're going to take a look at is a confidence interval method. So with our confidence interval method, let's again jump back to StatDisk. There at the bottom, we have the confidence interval that's given. Notice they gave us a 90% confidence interval. We'll talk about that in a minute. But our confidence interval is 1.685 to 2.137. 1.685 to 2.137. So since our confidence interval, so we identified our confidence interval. Since our confidence interval, this interval from 1.685 to 2.137, since that contains this hypothesized mean, the mean that's in our null hypothesis, it contains 1.800. Because it contains that, it is reasonable to believe that the mean is 1.800. We do not have evidence of the alternative. One other quick thing I mentioned real briefly was we had a 90% confidence interval. The reason we have a 90% confidence interval is because we have this one-tailed test. So we have this 5% over here. We kind of artificially create a second 5% over here. so that we have 10% in total. And so we are looking for like this range of values here that's between them for our confidence interval. And we're saying if we are in that range of values, if our confidence interval does in fact contain this mean value, then we're going to be all right. All right, so next time we're going to take a look at a different example for coming up with a mean for a confidence, doing a hypothesis test with a about a mean. All right, we'll talk to you then.